I always thought that by pressing a red-hot steel billet can be turned into steel until I learned about hot and cold rolling processes. I realized that it is clearly a control of temperature, stress, and speed. When the hot molten steel comes out of the furnace, it is quickly poured into the ladle and then flows into the continuous casting mold from the bottom. The molten steel is quickly shaped. It becomes standard-sized slabs. Then a bridge crane picks up the slab and gently placed on the transfer track and slide along the track, and finally lifted into the heating furnace. The temperature is quickly raised to around 1,200 degrees. The key to heating is to bake every inch of billet. If the heating is uneven, the steel produced later, the performance will be greatly reduced. But there is an unavoidable problem. Due to the contact between oxygen and a thick oxide scale will be formed on the surface, which will be pressed into the steel during subsequent pressing, thus affecting the quality. Therefore, we need to use high-pressure water of hundreds of atmospheres to spray the billet. After cleaning the surface oxide scale, the deformation process begins. Next is the rough rolling. The rough rolling machine uses a 4-roll combination. 2 large driving rollers rotate in opposite directions. Driving 2 small steel rolling rollers. The small rolling can withstand high temperature and wear. The billet is pressed thinner layer by layer. Finally, through several 20-centimeter thick billet. But this is just the beginning. The fine rolling is the real challenge. Unlike rough rolling, the rolls here can be tilted and fine-tune the curvature. It can not only strictly control the thickness tolerance, but also adjust it into a specific steel type. This basically determines whether the finished product is or fine steel. The next cooling directly determines the performance. It becomes harder and more brittle when it's cooled slowly. It becomes soft. You need to control the cooling rhythm according to make the steel meet your needs. Finally, these dozens or hundreds of meters of steel strips, steel coils. At this point, the steel can be delivered to customers. But if you want thinner and smoother, with higher precision and strength, cold rolling is required. As the name suggests, it is carried out at room temperature. Before that, the steel strip needs to be further oxidized skin and oil stains on the surface. Then, in the rolling, the steel belt has to withstand up to several tons per square centimeter. Here is a key point. If it is only pressed hard, the steel belt will be scratched or even torn. During this process, water-oil emulsion should be continuously to form a thin protective film to prevent direct contact between steel and under the action of multiple rolling mills. The steel belt becomes thinner. Finally, it not only becomes but also has a better flatness. The thickness tolerance can reach the micron, which is dozens of times thinner than if you want to get a specific shape, you can put the cold rolled steel plate into the mold and use a punch press to press out various shapes to make car doors, home appliance shells, and so on. Have you learned it? If you want to learn more in depth and interesting science videos, you can go to the Douyin. Select there are many science verticals like me and high quality bloggers to explore more interesting knowledge.